Can you hear me now?
Yes.
Great. So thank you for the nice introduction. So before starting, just want to let you know that these slides are already available online. You have the link in there, top right corner. So I'm going to provide you some examples and some links. So maybe if you can follow the slides on your mobile phone, it's easier to just check something else if you want to spend more time on a slide or on a link. So, hi everybody, I'm Luciano. Apparently I have the most beautiful name of the conference, thank you. So I am a full stack engineer with Planet 9 Energy in Dublin. I have to clarify that I kind of like the term full stack, even if many people hate it. As long as you say, yeah, I like full stack, but I am stronger on something. You cannot be like front-end, backend, DevOps, I don't know, UX, UI, and everything else. So myself, I would say I'm more stronger on the backend part of the full stack development. So hopefully I'm not going to be ashamed by showing you my front-end stuff. So basically with Planet 9 is a company that is working in the energy industry. We solve two problems, especially in the UK market for big consumers of electricity like industrial companies like producing, I don't know, frozen food or things like that. So a company that spends millions of pounds every month in electricity. And we solve two main problems, which are allowing them to have visibility on their bills, like to the very level. Every half hour they can see where they are spending their money. And then they can access the wholesale market, so they get a lot of advantages in prices and they are able to resell electricity if they have to. I'm saying this because we work in the, basically it's a big data problem, so we work with cool technologies like the Spark stack, so Cassandra, Scala, but we also do a lot of things with Node.js, Lambda, serverless. So if you are interested in those things, please come to talk with me after the talk. So I say that I work and live in Dublin, but I am actually Italian, specifically from Sicily, and to be even more specific, I am from this little region here between the volcano and this place here that was called in very past time Naxos, and apparently it was the very first Greek colony in Sicily. So given this, I'm even happier to be here with you. I feel like a bit more close to home. Then probably you don't care about my personal life, but there are two things that you might care, that I'm very proud of. One is that I am the co-author of this book, Node.js Design Patterns, which also features an entire chapter about universal JavaScript. And if this is not convincing enough for you to buy the book, there is a discount in there. And the second thing is that I am the co-founder of this little thing called Full Stack Bulletin, which is a very simple newsletter, weekly, focused on full stack developers. So you are going to find every week 7 links that are somehow interesting if you are into the full stack development space, or if you just want to improve your knowledge and expand your knowledge into other topics, like if you are a front-end, you want to learn more about backend, database, DevOps, and this kind of stuff. So sign up, it's great. And I swear, I'm not going to talk about myself and my stuff anymore from now on. So I can go away. No, done. Okay, the agenda for today. So I was a bit impressed that I was talking this day with many people and they didn't even know what we mean with universal JavaScript. So it's very good that we are going to start by explaining what we mean in the industry when we say universal JavaScript today. Then we are going to see which companies are already using universal JavaScript, most importantly why. And then if you want to start to build some universal JavaScript application, you are going to face some common issues. So we are going to explore all of them. And then finally, we are going to build a real application, very simple one, but it's going to give us a feeling of what it looks like to build a universal JavaScript application. And initially, this application is going to be a very simple React single-page application, and then we are going to change a few little things to make it universal. And of course, the goal is to show you that it's not that difficult as it might seem if you just try to look online. Okay, so about universal, what do we mean? So you probably heard before about isomorphic application. How many people knows about what is isomorphic? Okay, and universal? Whoa, not bad. Anyway, okay, so basically with isomorphic, let's do a bit of history before. So when we started to build a single page application, there was this issue that you were doing basically most of the business logic in the front end, like routing and like fetching data from APIs and rendering stuff. And at the same time, in the backend, you probably had another language like, I don't know, Ruby, PHP, Python, whatever. So there was an issue that every time you needed to do something that was operating with the backend, like routing, for example, you had duplicated code. Like all your routing rules were defined either in Python or whatever other backend language, and then in the front end in JavaScript, right? But at some point, we had this magic thing called Node.js, so we can actually start to write JavaScript code also on the backend. So some people started to explore this idea, oh, maybe I can share most of my front-end JavaScript code with the backend and vice versa. So I'm gonna kind of try to decrease this duplication. And this was called isomorphic JavaScript. So being able to share most of the code between front-end and backend and vice versa. But at some point, all these people in the community, you know, they like to change names. Like we have ES6 and tomorrow became CS 2015 and nobody knows what we are talking about. The same thing happened with JavaScript, isomorphic JavaScript. One day, this guy called Michael Jackson, which by the way is not the singer, wake up and said, okay, I'm gonna write a post. I'm gonna change this name because I don't like it. And then it became universal JavaScript. So if you are interested in the full story, you can read the post in this link there. But interesting to see that this approach of trying to use JavaScript, let's say in a universal way, and that's maybe the reason why the name makes sense, is not only for the web, it's happening also in other fields. Like we can build today desktop application completely in JavaScript. So we might access services that are written in Node.js, but also the front-end part of the application is totally written in JavaScript. For example, if you're using Electron or something like that. And the same is happening in other fields, like mobile development with React Native and other tools. But there are even people crazy enough that they do this thing for driving things with hardware and building robots and stuff like that. So universal JavaScript is becoming something bigger than just the web. Okay, but now let's see why it's cool and why you should use it. So I told you that universal JavaScript means being able to share as much code as possible between things that typically we're living in two different stacks. So let's say, I don't know, the front end of a web page and the back end. And one of the most evident probably advantage is that you will write code only in one language most of the time. So the context switching between doing an API and using the API in the front end is very minimal. And this leads to have code that is probably more maintainable and your team is probably more cohesive because they can collaborate easier in different parts of the application. But there is another very, very important topic, which is that if you build a universal application, since you can render the content either in the front end and in the back end, you can always give to search engines the actual content of every section of your website. So this leads to have a better search engine optimization. And it's not just that. For example, with universal JavaScript, we can solve another issue that is very important for search engine optimization, which is returning the proper status code of a page. For example, I don't know if you ever build a single page application and the moment you need to manage a 404 page, actually Google is indexed as a content because it's a 200 page for Google. You have no way to tell Google, oh, this URL doesn't even exist, unless you start to do fancy stuff from the server point of view. And instead with universal JavaScript, we can manage this as well, and we will see how. And then another very important thing is that since you render everything the first time that the user accesses a web page from the server, the browser, even before loading the JavaScript part of your application, will have everything it needs to start to show things to the user. So basically the user will feel like the website is loading faster, which is not necessarily true, but it's just the feeling that you have seeing the rendering a few seconds before. And of course, there are more advantages. Like as soon as you start to deep dive into these techniques, especially if you are an experienced React developer, Angular, or whatever framework, you can see that you can use the same approaches also to build static websites, because at some point you can just render a static HTML, but you still keep all the tools and the things you like about the framework you generally use for single page applications. And then you can start to use also other techniques like link prefetch and other things that are a bit more advanced. So if you are interested, there is a talk in there from, I think, Guillermo Rauch in one of the last React conference that explains all the optimization that you can do on top of universal JavaScript. Okay, who is using this technology? Uber, Netflix, Airbnb, WordPress, Dropbox, so very, very big names. So it's not something stupid, it's not just an experiment. It's something that is used by real businesses with a huge number of users. And I encourage you to go to those websites and just check the source code and trying to do a little experiments and see how they are using this thing. But now it's opinion time. Let's see what Mr. Potter thinks. Looks cool, right? But yeah, maybe it's very complicated, because if you start to look online for information about this, everybody says, yeah, it's not easy to start, there are so many problems, so many technologies, and we will see why. So there are different concerns that you need to address as soon as you are into universal JavaScript. And basically all the concerns are around how do you create these connection layers between the frontend and the backend. And there are different connection layers. For example, one of those is creating your own module, right? Because if you are used to do Node.js development, you are used to do very small modules and import them as soon as you need them. So you build little functionalities, and then you have modules requiring those functionalities, and you cascade this approach everywhere in an application. But of course, in the browser, you don't have really the same approach. Like, you tend actually to create a single file, and there was an amazing talk before, so thank you, Avram, for introducing this concept. So the issue that they are addressing is like, how do you merge those two different approaches? And we have tools like module definitions that can be used across the two different stacks, backend and frontend, like UMD or System.js. And as well, we have tools that allows us to resolve the dependency graph and create a single file with all the dependencies you need for the browser. So you're going to keep the same experience that you are used to in the backend with Node.js and small modules, and at the same time, you will be able to produce a single unified JavaScript file for the frontend. Same concern, like we said, we will need to be able to render our HTML both in the front end and in the backend. So we need tools and facilities to do that. And the major frameworks, every one of them has its own way to do this. Like React, Angular, Next.js, you can check all those tools. But the thing is, there is this need, we need to solve it somehow. Which tool should I pick? So this adds more complexity. And same thing for routing, right? I am in this URL, and the server needs to know what is the content for that URL, but then as soon as the page is loaded, I want to click somewhere else and move to another section. And on the browser, so just on the client, I need to change only the minimum amount of things that need to be changed to show the new page. So there is this constant switching of rendering between the backend and frontend. And as well, there are tools and technologies like in React Land, we use very often React Router, but there are also more framework agnostic libraries like Router 5 and Universal Router. And of course, it's not over. When it comes to fetch data, you have different tools to do that as well, because you will need to make API call in the backend and in the frontend. Okay, I'm gonna stop 1 second.
Sorry, yeah, we lost
no worries.
Somewhere around here.
Was it found?
With us. I'm very sorry. No, let's continue. We're gonna fix it afterwards.
Okay. So I was saying that same issue with fetching the data, right? Because you can make API calls with.
Sorry.
No problem.
The magician of the Potter.
Yeah. So let's rewind. So we saw that you have all these problems. How do you share modules? How do you do rendering in both backend and frontend? How do you do routing as well? And then how do you fetch the data? Because when you do a single page application, you just do AJAX calls with whatever library you like to do the HTTP requests. But then there is this issue that you don't want to use another approach when you are on the backend because you want to share more or less the same code. So there are libraries around that. One is HTTP proxy that allows you to solve like cross-origin problems. So you can expose an API that lives in another domain in the same API in the same domain where you have the front end, so that it's easier to call it. And then you have libraries that can be used without any change, either in the backend and in the front end, to do HTTP calls, like Axios and Universal Fetch. And then again, there is this thing that is getting very trendy, Redux and MobX and Cerebral and whatever framework you like to use for state management. If you start to use that, you need to have facilities to use it in a universal way. And there are, again, libraries and tools around that. So you are starting to see why it looks complicated from the outside. And there is more, because of course we are all about transpiling those days, and we want to use all the latest fancy stuff. And so people like, I don't know, TypeScript, somebody likes CoffeeScript, if somebody still uses it. But yeah, there are different technologies, and as soon as you start to write in those, let's say, supersets of JavaScript, you need to have facilities to transpile to something that works either for the browser and for the server. Okay, opinion time number 2. Why you have to go and make things so complicated? I don't know why, honestly, I don't have an answer. But I can tell you that we are developers, so we are here to solve problems. So let's stop complaining and let's try to start to build something. Maybe with an example, things are gonna look easier. So we are gonna build a little application. I am a big fan of judo, the sport. And I already wrote a tutorial originally about universal JavaScript. And basically what I want to build now with you is like the updated version where I'm gonna use the latest version of React, Webpack, and all this good stuff. And the application looks more or less like this. So basically you have an index with a list of people, and then you can click in every athlete and you get more details, like, I don't know, their own medals, their Wikipedia page, wherever they are from. So very simple, right? It's probably a very common use case to have a list of things, and then you can click and get more details. And of course I put this guy there, the first one, Iliadis, which I hope all of you knows, being here. So just to understand better how this application works, it's a single page application, and to see that you will see that we can enter any page. The first time we enter, we will download, you will see on the right hand side, the HTML part, which is provided by the server, and then of course we download all the CSS, the images, the JavaScript bundle, which we will see later on how to create that. And at some point we decide from this page to move to another page. And what happens is just that we download 3 extra more resources, so we don't do any other server rendering or stuff like that, because we just need to move to another section and load the images that we need there. The browser can do everything to move to the next section. But as well, apart from being a single page application, when we are rendering, when the first time you are accessing any of those pages, the server is able to produce all this code, which you don't need to read it, of course. But the idea is that it's not just a template HTML with, I don't know, a div that is empty where you will load the application in the JavaScript file. You actually have all the data that a search engine can read to understand what they are actually displaying in this page. Okay, as I told you, we're going to use React and also Webpack 2, React Router, and Express. Not necessarily because they are the best technology to do this, it's just because they are the technology I'm familiar with. But probably if you're used to Vue.js or Angular, you will have a very similar approach to what we will be doing here. So you don't need to stick to these technologies. Okay, so the first thing to do to start our project is to install dependencies. We are using Yarn because we are cool and has a cool name. And basically the things we need is Babel, And of course, we want to use as well all the fancy stuff of ECMAScript 2015, like modules. And so we need to be able to transpile this code into something that works in every browser. Then we are going to need to use a little template language just to do very simple stuff. So we are going to use a.js, Express as a web framework, and then React with React DOM and React Router. And finally, we also need to use Webpack to create the bundle for the browser. Okay, how the structure of the project looks like. I'll move a bit. So we have a first folder called source components, where we are going to store all the React components. Then we have data. And this data, I want to clarify that is just a big JSON file that we will see in a moment. And at this stage, we don't care much about implementing a real API, okay? Because we want to keep things simple, and then the next step will be having real API. So for now, we take all our data from a big JSON that is shared across the application. And then we have, of course, static resources. So we have images, CSS, and compiled JavaScript for the browser. Then we have a little HTML template that we will see later. And finally, we have an entry point for the browser and an entry point for the server. And then, of course, configuration, metadata, package.json, and so on. Okay, so this is the data. Let's see how it looks like. So basically, it's a big array, and in this array we have object, and every object describes an athlete. So you have the ID, the unique ID, a name, the country, which is another object, the birth date, a couple of images, a link to Wikipedia, and then another big array with all the medals for every athlete. Simple, right? Now let's move to the React components. And here as well, I want to thank you, Nir, because yesterday did a nice presentation that I hope you saw. And we are going to use more or less the same approach in creating components. So we are going to split the view into a hierarchy of components, and basically we are going to have 3 levels, where the first level is layout, which includes everything. Then inside the layout we have pages, and then inside pages we can use different micro components that solve specific UI issues. So the top level component is this layout component, which basically you can think about it like an header, a content area, and a footer, so very simple. And then we have pages. The first page is the index page, which is just a list of athletes. And athlete page, which is actually when you click into one of those athletes, you just get to this page. And then as well, we want to manage 404s. So if you input a wrong URL, you want to see a meaningful message that says this URL doesn't exist. But then, as I told you, we have helper components, so lower level components. So for example, this card that represents a single athlete, and it's called athlete review. Or I don't know, this menu here on top, or other small things like displaying a flag and the name of the country, or displaying all the information of a medal. So you can decide how to structure your components based on your application need, but more or less you're going to have a hierarchy of a big component that includes subcomponents, that includes minimal components. So let's start to see some code. I don't know, many of you are familiar with React and JSX. Can you raise your hand? Okay, great. So it's going to be a bit easier. So basically the idea is that with React we can create these pure functions where basically you are passing as an input a set of properties, and then you need to return something that represents a DOM structure. And in React you can use this language called JSX, which looks very close to HTML, and it's the way that allows us to take properties in and create a HTML structure out. So in this case, we just want to create a basic structure for our layout. So we have the header part, that is the one in orange there. Then we have a content, and here you have to notice that we are using props.children, which we will see in a moment allow us to include dynamic components inside, which is going to be the specific page that we need to use in that moment. And then, of course, we have some other piece of HTML for the footer. So I think this is very simple. Then let's see how a page looks like. I'm not going to show you all the components. I just want to give you a feeling of about how every component looks like. So in here, we actually need to receive some input because we are starting to display things related to the data that the application needs. So we are using here ES 2015 destructuring, which basically means, if you're not familiar with this, that we can receive an object, but from this object we care only about the athlete's property. And inside the rest of the function, you can reference directly the property. So it's just a shortcut to write things in a shorter way. And what we want to do, we create those divs, but then we want to say, okay, but for every element in this array, I want to render other components. So the way we do this is just by using a map function over the athletes variable. And we render the athlete preview component in there. So the athlete preview looks like this. And again, we receive properties in. Oh, sorry, I want to clarify something. Look that here, when we use the athlete preview, we are passing a key, which is just the ID of the current athlete, and then athlete data, which means that all the properties that belongs to that specific athlete are passed over to the next component. So every component will get only the minimum data that it needs to render. And of course, in this component, we get props, as you can see there on the function declaration. And we use all these properties as data for this component. So the first thing that we create is a link all over the component, so it makes the component clickable, and will move us to the page of that athlete. So you see that we use props.id. Then we have an image, then we have the name, and we are using again props.image and props.name. And then we have another little widget that allows us to display the number of medals won in several competitions by this specific athlete. So you can see how this abstraction allows us to render all the athletes. You just need to provide the right data. Now that you have an idea of how the components look like, let's move to the routing part using React Router. And basically, it's very simple application, so we just need two routes. One is the index route, which is just slash. And then we have a route, which is the specific one for the athlete. So we're going to have athlete slash the ID of the athlete. So we need to use React Router. And to do that, we create an higher level component called app.js that incorporates the React Router. But also you notice here where we have the last import, athletes, and we import from data, that we are embedding all the JSON in there. So this is just a simplification, right? In real life, we will be doing an API call there only when needed. But it's important to know that that data is there because we are going to propagate this down to all the components. So how do we declare the routing layer? React routers give us this component called switch, which basically works like the first route that is matched is, let's say, executed for now. And executed means that you can either call a function using the render option, or you can just specify a component if you have already the instance of the component. In this case, we want to use a function. So here we are using render index for the index page, and render athlete for the athlete page. And of course, we also have a default route without any path condition. So if none of the previous path matched, we are going to default to the 404 component, not found page. But how the rendering function looks like. Again, we are just writing pure function, so it's very simple the way that React allows us to do those things. And for the index, we just need to invoke to instantiate the index page and pass the athlete array to that. And we saw before that the index page accepts just an array of athletes. Instead, if we want to render the athlete page, it's a bit more complex because in the athlete page we receive an ID of the current athlete, so we need to do something with that ID. We need to verify if actually in our little database, in our little JSON file, we have an athlete with that ID. And we do that with the athletes.find. And of course, if there is no athlete, we just want to render a not found page. Otherwise, we will render the athlete page and pass over all the data that we found in our little JSON database. Okay, so we are getting close to see it live. So one of the latest thing we need to do is to create the entry point for the browser, which basically means that we need to make aware that this React application needs to be loaded and placed somewhere in the DOM. And also needs to be aware that the routing layer that we want to use is for the browser. So that's why we import the browser router as router. And the browser router is a special kind of React router that is also able to update the browser history every time that we change the URL. And it's very simple because you just need to wrap the application that we saw in the previous slide in this router component. That's it. You don't need to do anything else apart of using the render method into a specific DOM element. So of course we need to put an HTML template there because of course it needs to live somewhere, this JavaScript. And the HTML is very simple. We are actually using a.js just because it's going to be simpler later on to move to universal, but it could be a plain HTML. And the only thing to know is that we are using that variable called markup that is going to be empty for now, so it's like we are not using it at all. And then we have this bundle.javascript. Okay, I could skip this part because that guy there did an awesome job, but I'm just going to be very quick to recap this. So we say that Webpack is useful because it allows us to combine all the files that we just saw into a single file that can be run on the browser. And to do that, we need to provide some configuration. One is for Babel, and we are going to use almost the default approach, which is just using React and ECMAScript 2015. And then for the Webpack part, we just need to define the entry point, which is app.client.js, the output, which is bundle.js, and then that we want to use Babel to transpile every single JavaScript file. That's it. That's all we need. And to run this, to compile actually this bundle, we just need to run Webpack, and that's it. You wait a few milliseconds, and it's done. One last thing, we don't really need this now because we can just run the HTML, but since we created a little template, we need to have facilities to render this template. And basically, it's a very simple Express application where we just need to say, I want to use a.js as a template language. I want to serve static files from this folder, like images, CSS, the JavaScript file. And then at the end, we just have one route that matches everything. You see the asterisk in there. And this route, basically what it does, it just always return a successful response, so 200, with the result of the template. So we are going to have a very simple HTML in there. So we are ready. Let's test this. Should have it running here. Okay, just take in mind that this is only the single page only part of the application. It's not yet universal, but let's see if it works. So we can move to the different sections very easily. But yeah, it could be anything, right? We don't really know what is happening until we open the inspector. So we want to inspect the network requests. And basically what we expect to happen is that when I refresh, there is a first call to the server, and we see here localhost. If we want to see a preview, it's just our template there. I don't know if you can see it, but it's obvious that there is no meaningful data in there, because right now we are rendering only on the client. And then, of course, the moment I move to another page, we just load a few images more, and a few other images. We don't do, again, requests to the server. And to prove the fact that we are not rendering on the server, if you just do, if we just check the source of this page, there is nothing. It's just our template code. There is no meaningful information for search engines yet. Okay, back to the slides. So just to recap, what we did was defining views using React components, so different layers of abstractions. Then we added routing across those views, and then we compiled our bundle file using Babel and Webpack. And finally, we just created a little Express server just because it's going to be easier later on to move to universal JavaScript. But we could have done this with a plain static index HTML file. So now let's make this application universal. So we want to add server-side rendering and routing. And you will be surprised that we just need to change one file. And this file is our server, so the Express application. And we need to change basically two things. One is that we should make this server aware of our React application, which basically means that we need to import a few libraries from React, and we need to import render to string from the server package of React. Then we want to import static router, and this router is a bit different from the previous one, because before we were using browser router. The difference is that static router doesn't need to care about updating the history of the browser because it's just rendering a string. So it's way simpler and way smaller, so it's better to use this on the server. And finally, we import all our React application into the server. And you might notice that we didn't need to do any change. Like, we took the code as it was for the browser, and it's there on the server. It doesn't matter if it's React code using JSX, because then the transpilation part is going to do everything for us. And then the next step, after importing all the resources that we need from the front-end part of the application, is to change a bit the rendering logic. So we still work with a single entry point in the routing layer, so an asterisk or a catch-all route. And this time we need to do some business logic. And the business logic is just, okay, I'm gonna create a little component on the fly. You see there, router, location. There we are instantiating an instance of the static router, and we are passing the current URL that is coming in the HTTP request and the context. And then basically we are wrapping the application that exists already. So, and then we need to manage just two cases. What happens if the current response is a redirect? Since you are in the server, you need to respond with an HTTP redirect. You cannot return just HTML. So we can do this by just checking if you have context.url. It means that we are trying to go to another URL and we need to create an HTTP redirect. And then there is another case. What happens if it's 404 and we have a flag into the context that tells us, okay, this route didn't produce any meaningful results, so we couldn't find the content for this route. So the status is 404. And finally, you can render everything by just saying, okay, this is the status, and render whatever is in HTML. And that's it. So that's really what we need. We don't need to do anything else. So now let's test this again. So this is the universal version of the same application. I just want to show you that it works exactly the same way. Scroll, we can go back. But now let's open the inspector again and let's see if there is any difference. So let me refresh again. So what happens the first time is that again we do a request to the server, but let's check the source code this time. So it looks the same, but this is just because we are in the home page. Let's go to an athlete page. And let's refresh. And this time, if we check the source of this athlete, you will see that there is a lot of stuff in there, right? And it's all the information that you are visually seeing there. So it's very clear that the look and feel of the application didn't change. We didn't have a lot of effort in adding universal in there. And we have all the advantage of universal. And the first of them all for me is that the website can be searched very easily by Google or whatever search engine. So back to the slides, we are almost over. So just to recap what we did. So first we created a single page application, and that's what we did in the first part, using React and React Router. And then we just needed to change a few things in the server file to say we want to support server-side routing and server-side rendering, still using the same React application. And we did everything using React Router, and Express. But yeah, this was just a very simple demo, right? Probably you're not going to build a website like this for a business. So what can we do from here? Like, now we have a foundation. We know how universal JavaScript works. If you want to start to do more serious things, what can we do? And the first thing that we will need to solve, of course, is start to add some interaction with real APIs. So fetching real data. Imagine that I didn't have a JSON file, but a huge database with all the judo athletes in history, right? I couldn't use the JSON, of course, but I needed an API with a database. And this adds a bit of complexity because you start to have asynchronous data, which means that you need to do, as soon as you are transitioning between one page and another, you need to wait for the data to be available. While in this case, the JSON is already there and you don't need to worry. So the rendering and the routing becomes asynchronous, and you need more complex stuff to deal with that. And there are a couple of different approaches and libraries that you can use. And I encourage you to check API proxy and async props if you are into React land. Or, of course, there is a full chapter in that book that I mentioned before. Next thing is that if you want to do, if you are already using Redux or any other state management technique, you, of course, need to integrate the same thing into the universal application. And if you are using Redux, there are libraries called Redux Universal or other variation of it that you can easily just plug it in the server, and most of the work is done for you. And finally, there is a very important topic, which is progressive web application. And basically, the question is, okay, can I do a universal application that is also a progressive web application? And of course you can. And the good news is that if you are used to use the toolkit from React, Create React App, in the last week, I think, they just published a new version that is already configured to give you universal application and progressive web application. Most of the things are invisible to you. You just install it, and it's magic. So I hope that with this presentation, at least you understand what are the basics that are going behind the Create React App toolkit. So that if you need to change something, at least you know where to look things for. And finally, if you want to see the source code of this example, everything is online on GitHub, and you have the link in there. So that's it for me. Thank you for listening. It's still a lot of effort, and I don't see any other way with, I don't know, let's say Python, for example, with which you can use a React application into Python and kind of interpret this JavaScript code just to create the HTML. Probably there are ways, but it's going to be very archy and hard to do it.
I know you can use server-side templates with Angular now, but I don't know about universal router and all the stuff. So, I mean, server template is done now. It doesn't matter what you use the backend. I don't know about the rest of the parts.
Yeah, unless, I don't know, let's say Angular, unless they create libraries for any language, I don't know, for Python to render the Angular components and everything else in Python, which I think is going to be a huge effort. So unless they do that, it's going to be very hard to do universal rendering without Node.js.
So to answer the question, I think it's possible. Any language that can transform how to JavaScript will work. So instead of using JavaScript, I can use ClojureScript.
Yeah, that's a good point. I'm going to repeat for the camera.
Yeah.
And the point is that if you have a language that can transpile to JavaScript, you can probably do a lot of things around universal JavaScript. I'm not sure you can easily import the React application into the language. Maybe you should import into the transpiled version. So probably there is a bit of configuration that you will need to do, but maybe it's possible if you can transpile a language X into JavaScript.
Any language that supports transpiling to JavaScript will have like a foreign function interface that you can call any JavaScript you want. So,
right. Any other question? Yeah?
I think another solution would be to use a headless browser.
To use a headless browser?
Yes. So launch headless browser, take the result,
yeah.
And whatever language you are using, you
so
can return the result. And I have a question.
Oh yeah, go ahead.
If we start processing on the backend and launching on the stack of the frontend, should we create a very big performance issue on the backend? Because if we think we run 2 times all the stack on the front end. One is on the back end and one's on the front end when the page arrives.
Okay, so two things, an observation and a question. The observation is you said to use an headless browser, right? And that's basically what happens with pre-render, which I was saying before. It's I think it's Phantom.js or something like that, that you configure to crawl your own website, like in JavaScript mode, like in user mode, and you store all the HTML every page you visit. So yeah, you can use any other headless browser. It's just that pre-render has a lot of tooling around visiting and storing data and creating like a proxy that you can redirect Google to. And then the second question is there any overhead in universal application? Because it's true that on one side, the first time the user tries to load one of the pages from your website, there is something happening on the server, and then this something renders a full HTML and a JavaScript file, and then something is happening again on the browser, because it's like you are moving to a new section and all your JavaScript actions are triggered. This is kind of true, but not 100% true, because for example, so regarding the server side, it's true that you have an overhead, because if it was a static website, you can use an S3 bucket or any other static website mechanism, and it's super fast, and you don't need to worry about scalability and things like that most of the time. Instead, having your own Express server brings in more complexity, because you need to maintain, you need to host this and auto-scale this server. And every time you receive a request, you probably need to do some server stuff. On the client side, it's not necessarily true that everything is happening twice, because with React, the libraries are smart enough, but I guess even with other frameworks it's the same, to understand that the first time you already have all the content in there. So basically they just do some little checks that doesn't cost much to the browser. So they don't re-render all the DOM over again, unless they see that the DOM is different from what they expect. So, and as well, if you use Redux or other stuff like that, they don't do the requests again, because you have ways to say, I already done this request and the data is already here. Any other question? Yeah.
Just a question again about the pre-rendering. Why do you need to serve a different version to a crawler? If you do a pre-rendered version of the website, why not send that to everybody and then use progressive enhancement then to let the JavaScript take over any future requests? Is there a value in sending the?
So the question is, why do we use pre-rendering instead of doing enhancement of the page, right?
Why do you send a separate page to two different requests? So in other words, the search bot as opposed to a regular browser? Yeah,
so why do we create this thing that if it's Google, we send it to some place where we have cached data, and if it's a real user, we send it to the actual application.
Correct.
So this is something, just to clarify this, that you do if you created a single page application and it's not a universal application. Okay, so most of the time I was doing this when I had e-commerce platform and all the backend was in PHP, and then the look and feel of the application was a single page application with Angular, I think it was at the time. So Angular 1. So there was no easy way to say, okay, let's create a pre-rendered thing, unless you have an headless browser going there and running all the actions that they needed. And then the issue is that when the user is coming in, you don't want to serve probably can change with your setup, but the simplest thing to do is that you don't care, like the user is coming in, he's gonna have a real browser, he will be able to render the real application. So you just send him to the real page, which the real page, given that it's a single page application, is just an HTML with a JavaScript file linked in with no other CEO information. Instead, when Google is coming in, you want to send it somewhere else because you created another page, which is the representation of that page already rendered. But you don't want all the users to go there because it will bring you to a more complex setup. So probably that's the real answer. It's not that you cannot do it, but at least with pre-render, the one I used was way more complex to integrate PHP on top of pre-render and then the single page application.
But isn't that like one of the very first things Google says not to do, is to send different content to a crawler as to user?
Definitely yes.
Okay.
And that's why universal applications are better, because they avoid you to do that.
Okay.
But at the same time, if it's true that Google realized that most of the content of the JavaScript counterpart, can read it, if they try to visit the page with different headers, so simulating that they are not Google but they are some regular user, it's very likely if they start to load the JavaScript as they say, that they will see most of the things similar.
Okay.
So the difference should be minimal. Probably they will not see some pages, but everything else they should be able to find it. So honestly I don't know for sure if you have benefits or problems, and that's why I will go for universal JavaScript, because it's safer on that regard.
Yeah. Thank you.
Yeah?
Server-side search engine optimization is many times mentioned as an argument to render everything at the server side.
Mm-hmm.
In real life, however, most of the applications that make sense, complex applications, are leaving behind a login screen, so are not accessible by search engine.
Yeah.
With that in mind, makes any sense to bother ourselves with that? Are there other advantages in order to move everything to the server side, or can we just, in this case, ignore that?
Okay, so the question is that in most of the modern applications, or at least complex business applications, like everything is leaving behind a login screen, which means that you don't care about Google, basically. Right? So the question is, in that cases, do you really need to care about universal JavaScript? Are there other advantages apart search engine optimization? And again, the answer is depends. So in our company, we are actually not caring about universal JavaScript, because most of the application is behind a login page. Only our customer can access the tools that we provide, and we don't care about Google. So there would be a very little advantage in moving to universal, so we are not doing that at the moment. And the advantage could be, and I invite you to check the talk that I was mentioning in the slides, that you can use some little techniques to optimize the experience of the user, like preloading different assets while they are in a page, and they probably are going to go in another page. So you can use some little tricks to improve the experience. But that's as well a very specific use case. Do you care for your application on saving, I don't know, 2 milliseconds for the users? There can be cases when you care, and maybe it's worth to have universal JavaScript, but probably you don't, so you don't need universal JavaScript in that case. I don't know if it replies to your question.
Yeah.
Great.
All right, I'm afraid that's all the time we have.
Thank you very much again.